Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent.
For the 16 years, onward of June 20, 1974, I kept moving forward towards the jagged frontiers of the parallel supercomputer. I moved forward even as vector processing supercomputer scientists mocked me and made fun of my belief that parallel processing will overtake vector processing as the technology that powers every supercomputer. I moved forward with my invention in progress because I knew that my discovery of practical parallel processing would put the name Philip Emeagwali into books on the history of science. My sense of urgency that history was in the making was why I spent 16 years working alone and unpaid, and doing so to invent practical parallel processing as the technology that makes every supercomputer super. As a research mathematician of the 1970s and 80s, my quest was for new algebra, new calculus, and new mathematical knowledge that was newsworthy and that was not in any mathematics textbook. The new mathematical knowledge that I contributed to mathematics that then US President Bill Clinton mentioned in his White House speech of August 26, 2000 was the Philip Emeagwali formula that I used to figure out how to divide the toughest mathematical problems into a million smaller problems and how to then solve those smaller problems across a million processors. I visualized my processors as tightly encircling a globe and encircling it as a new internet and encircling it in the manner the internet circumscribed planet Earth. The most productive decade in my research for new computational mathematics was the 1980s. In 1981, I was an extreme-scaled computational research mathematician in College Park, Maryland, United States. College Park is a small town of 30,000 residents in Prince George's County. College Park is to American mathematicians what Abuja is to Nigerian politicians. In College Park, Maryland, I identified myself as a research computational extreme-scaled mathematician that was at the intersection of numerical analysis and the partial differential equation. Those two fields of study are at the crossroad where physics, applied mathematics, and computer science met. Those two fields of study are particularly useful to physics, engineering, and medicine. Each afternoon and at the blackboard in the mathematics coffee room in College Park, I might scribble a system of partial differential equations of calculus that is impossible to solve directly, as well as its companion system of partial difference equations of algebra that I hoped to solve across my new internet that is a new global network of commodity off-the-shelf processors. Once again, it's impossible for any mathematician to exactly solve an initial boundary value problem of calculus that is governed by the 9 partial differential equations that I invented and that are my contributions to calculus. My solution strategy was to move away from my blackboard and to do so by paradigm shifting to a new internet that is a new global network of 64 binary thousand processors that were identical to each other, that were tightly coupled to each other, and that shared nothing between each other. Each of my 65,536 processors operated its own operating system. College Park is 4 miles from the northeast border of Washington, District of Columbia. In 1981, I was living at 1915 East-West Highway, Silver Spring, Maryland, rather than in College Park, Maryland. I lived in Silver Spring, in part because it was midway between the city of College Park and the Foggy Bottom and Adams Morgan neighborhoods of Washington, District of Columbia, and the National Institutes of Health, Bethesda, Maryland. Those were my favorite places. In the early 1980s, my wife Dale was conducting her own research in the field of molecular biology. On my typical weekdays of the early 1980s, I arrived at 8 o'clock in the morning at my desk in the Graymax building at 8060 13th Street, Silver Spring, Maryland, United States. In the 1980s, the Graymax building housed the United States National Weather Service. The Graymax building has been reconfigured as an apartment building. At 12 noon and on weekdays, I will take a shuttle bus for the 25-minute ride from Silver Spring Metro Station to College Park, Maryland. In College Park, I spent a lot of time in the coffee room for research mathematicians that was at 4176 Campus Drive, or inside the nearby research library that had specialized collections of mathematics, physics, and computer science. Or I might be attending a research seminar on new mathematics that is given by a research mathematician that is visiting from a different country.
Insightful and brilliant lecture.